Start our recording. So we're going to be looking at Module 1 this evening and completing the practice problems for that section. The practice problems are going to lead into and give us insights and formatting for the application problems. We are not working out of the textbook for this particular module, okay? So if we look at the learning plan, we're going to be doing our demonstration. It does say read chapter 1, but you don't have to. There's not going to be information pertaining specifically to what we're going to be doing here. We're just going to be basically doing our math review, okay? And then you'll have the practice problems and the application problems to hand in. So what we're going to focus on are the the practice problems. So if we click on the practice problems, you're going to notice that there is a link here to the PDF. If I click on it, it is going to be here. Now, for those who are virtual, you don't need to print this off. For those who are in class, I print off any handouts that we have for a particular module, so you get the benefit of that. And the hard copy is here just for reference. You won't be handing in the hard copy. Yes.
This is what we will be scanning.
You won't be scanning this at all. You'll only be scanning your work. So we'll be going over that in just a bit. But this is, if you would, like a worksheet if that we're going to be doing. So at the top here, it says Module 1 practice problems, 10 points if you complete it and it's done as demonstrated during our lecture demo, okay? 0 points, either not handed in or you didn't follow the formatting or didn't do all the problems, okay? So it's kind of like you're either do it or you don't, okay? You're not getting an 8, you're not getting a 7, you're getting 10 or 0 on all practice problems, okay? You only get one chance to submit, as we talked about in the syllabus, all right? These are due this coming Friday. That's their set due date, but you have a 7-day grace period to get them in, okay? So I don't want anybody stressing to try to get them on Friday because remember, you do have 7 days, okay? But we will be working them all tonight in class, so you'll basically have them done if you follow along when we're done with class here, okay? So that's why I encourage you to always have pencil, calculator, paper ready to go so that, like I said, once we're completed with class, you should be pretty set. Will we have more of these sheets on Monday? I plan on being there on Monday. You mean like because we'll be starting module 2, Ava. I have to look at module 2. I haven't looked that far ahead. I forget. Okay. So if there are practice problems in module 2, if you want to peek ahead, then those will be there. So yeah. Okay, so now the next thing it says, follow along with our lecture demo in Module 1, work the following practice problems on a separate piece of paper. So you want to get out a piece of paper. It can be lined, it can be not lined. I have some extra paper if anybody needs some in the room. So you're just going to work this on an extra piece of paper. Does anybody need paper if you're in the room? You do. Okay. Grab them over here. There we go. Okay. Well, it's up to you. Or you can get 2 or 3. It's fine. So we'll have that up here. So if anybody needs extra, it's there. Be sure to show the original problem and all the steps taken. So again, I'll be mimicking that as we go through the problems. You want to put a box around your final answer. I don't want to have to hunt for your final answer. There are 17 people in class and I get to grade everybody's work, okay? And I don't mind grading, but I also don't want to try to hunt and try to figure out what you're trying to tell me, okay? So part of this is, relaying the information, communicating to me how you did the problem, okay? Use pencil, all right? Because if you make a mistake, I want you to erase, not cross out and, kind of scribble things, out there. No, you're handing something in a professional manner, showing me how you went through the process, okay? And don't forget, if I can't read it, it's wrong. I'm not going to try to squint and figure out, is that an S or is it a 5? Is it, what is it? If it's fuzzy, if you're handing something in, check your files when you do the scanning with your app before you actually submit, because if I can't read it or if it's fuzzy or blurry, it's a 0. Okay. So make sure that you're taking those steps. This assignment is graded again either 10 or a 0. We'll be working each one of these problems during class. To earn all 10 points, you need to complete each one of the problems and show the formatting that I'm showing you here in class. This formatting then is how you're expected to hand in the homework. Okay, that's the whole kind of the whole point of the practice. Okay. If you have any problems or if any of the problems are missing or not, or the formatting is not followed, you just don't earn the points. All right. So I I want to make sure that you know exactly what's expected right here at the beginning, okay? Because this is how the rest of the class is going to go. And you're going to find that not only myself, but other instructors in the program kind of expect the same thing when you're handing in work as well, okay? All right, so I have this little 2 asterisk. It says, make sure to write all of the original equations in an up-down, not a slash format when fractions are present. And I'll demonstrate that in a little bit. So let's look at what we have here. I'm going to zoom out just a little bit. So on this sheet, it's a 1 page. Okay, it's just on this 1 page. And there are 1, 2, 3, 4 sets of problems. Okay. Now, when you hand in, you don't have to worry about like saying this is module 1 because you're going to be uploading it to the module 1 homework assignment. You also don't have to even put your name on it or the date because I'm going to know who's handing it in because you're handing it in underneath your person. It's labeled and I know the date that you handed it in. So as far as header, we can just start kind of working and I'm going to start by looking at set 1. You don't even have to write algebra. You're just going to say set 1. So I'll zoom back. I'm going to zoom back in so I can see my first problem here and we're going to start right here. So I'm going to go underneath my camera. I have a blank piece of paper and I'm just going to start with set number 1. That's it. And then that way I know that's the section that I'm working on. Something I do like, all right? And if it happens sometimes when you're uploading, especially when you have separate files, to hand in things in the order that it's given. So for instance, if you're working these problems and you do number 1, number 2, but you skip number 3, leave space for number 3 because then go back and put number 3 in that spot because it's so much easier for me to go through in the order. Okay, it might not seem like a big deal, but if you're the person correcting 18 people's work, it's kind of nice to have it in order. If it gets out of order, don't worry about it so much, but make sure that you're labeling it and try to, keep things sequentially. So what we're going to do is it says here for problem number 1, solve for V. And then directly below here, here's the equation. So we're going to be practicing algebra here and making sure that we, can rearrange this to solve this equation for V. So I'm going to first write out the original problem. Okay, you're not just writing me the final answer. You're going to first write the original problem. So we're going to say number 1, and this is D is equal to V times T2 minus T1. Okay, just as we see it there. And I'm going to go back underneath here. And that's how I have it written. All right. Now this is asking me to solve for V. You don't have to write out solve for V. You're just going to now rearrange and solve for V. So to solve for V, since V is on the right-hand side of the equal sign, you can leave it on the right-hand side of the equal sign. That's how I would probably, do it. So because V is multiplied by the quantity of T2 minus T1, I'm going to take that entire portion, and because it's multiplied on the right-hand side by V, we're going to divide it, if you would, on both sides to, get it on the other side so V can be by itself. So all I'm going to do is I'm going to say D divided by, I'm going to put my T2, minus T1, okay, underneath is equal to V. And that's it. All right. If you wanted to, some people like to put that intermittent step where you have divided by on both sides and then it cancels. Feel free to do that. This is the minimum I need. All right. If you want to add extra steps, that's totally fine. Okay. And then once you have it in its final form, you're going to just put a box around it and that tells me that's your final answer. Okay. Can you circle it? Sure. I'll let you circle it. Yeah. Does anybody want to put, you could put a smiley face next to it if you want. No, no. Circle or box. How about that? Circle or box. I'm good with that. Okay. All right, then let's look at number 2. Go back over here. Number 2 is we want to solve for R, and it's I is equal to E plus E, uppercase, lowercase, divided by R. Now, this is where that asterisk is. If we go up here a little ways, it says make sure to write all the original equations in the up, down, not slash format, okay? So what they're referring to here is that when we write this out, we want to do I is equal to E plus E divided by R. So up, down format. Don't do the slash. As you know, then all of a sudden it's kind of like, is this on the top or is this on the bottom? And we want to make sure that we're getting our algebra right. Okay. So make sure you show it in the up, down format here. And in this case, we want to solve for R. Okay. So because R is in the denominator on the right-hand side, to get it, if you would, up on top so that we can solve for it, we're going to multiply by both sides. So this is going to end up being, I'm going to put R times I is equal to E plus E on the right-hand side. And then to get R by itself, we're going to divide both sides by I. So R is going to be equal to E plus E. If you want to keep that in parentheses, that's fine. And then I underneath. Okay. And then a box or a circle around our final answer. Okay. Bless you. Okay. Bless you. So the important thing here is that I can see what was the original equation, and then whatever it's asking to solve for that variable. Notice that we could do it pretty much in one step here because there was only one, division. Here I ended up doing it in 2 steps just because there was kind of 2 steps. As long as I can see the progression along, I'm not dictating like how many steps you do it in. All right. But I need to see some work to make sure that I can, decipher your process. Okay. During this time, or even virtually, if anybody wants to be like, hey, can I show you what mine looks like? Is this what you're looking for? I'm absolutely happy to do that. Okay. All right. We're also getting to know each other, if you would. You're getting to know what I expect in these first assignments. I'll write notes and be okay, but do pay attention to what we're doing here in class, right? Okay, let's look at number 3. Okay. Number 3, we want to solve for H, and here's our equation. So I'm going to write that out over here. Make sure, again, we want our fractions in the up-down format. So it's this one right here. So P is going to be equal to BH times 1 minus A on top divided by 2D. And we're going to solve for H. So we want to write it, again, up-down format should look something like that. If you want to add the extra parentheses, you could, but I kind of left them off. They were there mostly for the, kind of writing it out in that Word document. Okay. So we're solving for H. So H is over here, all right? So the first thing is I want to get rid of my 2D, and I'm going to put it up on top on the other side. So I'm going to put 2DP is equal to BH times 1 minus A. Okay. Then keeping H over here, I'm going to take my B, I'm going to divide it on both sides. So I'm going to go underneath here. I'm going to kind of put a slash here. So this is going to be B. And then I'm going to do the same thing for 1 minus A. Okay. Now, this isn't in its final format. It's kind of the work that we did. So we want to do one more time. 2 times dP divided by B, 1 minus A is equal to H. And then that would be our final answer. Does that make sense? Okay. Looks fun, doesn't it? I bet you guys are like, I can't wait to do the homework. I don't blame you. I know. You get to do statics homework. That's what you get to do for the next 8 weeks. Okay. Any questions? All right. Let's do number 4. All right, now I write big. You don't have to write really big, but don't write too small. All right, make sure I can read it. That's the important thing. Okay. So number 4. All right, I'll go back over to here. So here we want to solve for L. All right, so on the left-hand side, we've got AL divided by H. So again, make sure we put it in that up-down format. And this is going to be K times B1 plus B2. And we're going to solve for L. Okay, so you want to write it out in that up-down format. Now, I feel like I can do this in one step, all right? So I'm going to keep my L out over here. My H is going to be multiplied up on top, so I'm going to put H times K times B1 plus B2, and then dividing all of that by A. Okay, that makes sense? Now, if you're bored and you're like, this is really easy, perfect. That's exactly where I want you to be. All right. Because this is the stuff that I'm not going to be explaining all the time. Does that make sense? Okay. The expectation is it's a prerequisite. And with the the calculus that you've done and such, you'll be good. Okay. Number 5. Let's go back over here. Number 5, we're going to be solving for R2. All right, R2 is going to be over on the right-hand side here. Again, this is a fraction, so we want to write it in its up-down format. So we've got E1 squared divided by E2 squared is equal to R1 divided by R2, solving for R2. So this is the up-down format that we would see. So R2 is going to be what we solve for. Okay. So I'm going to multiply that up first. So it's going to be R2 times E1 squared divided by E2 squared is equal to R1. And then now I'm going to kind of do that crossing out. I'm going to do my E2 squared is going to go up on top. I don't know if you do this, but if it's divided on one side, I like to say I'm going to do the opposite on the other side. So it'll be multiplied on the other side. This one is multiplied on the left side, so it's going to be divided on the right-hand side. So the E1 squared goes underneath. And then now this isn't final format. All right, the E1 cancels there. I'm going to have R2 is equal to R1 times E2 squared divided by E1 squared. Like this. And then I'm going to put a box around my final answer. It's messy. Okay. The last problem in this section is number 6. Okay, number 6. I'm going to let you do that one by yourself. Okay. So number 6 is P is equal to 2L plus 2W. And we're going to solve for W on this one. Okay. So I'm going to go back over here. And this one is written just as you see it. Okay. So we're solving for W this time. So the 2L is positive on the right-hand side. To get it to the other side, we're going to subtract it. And then that leaves 2W. So to solve for W, I need to divide both sides by 2. That's your final answer. Okay. All right. Any questions? Yes.
How picky would you?
I am so picky. What do you mean?
So if I put P.
Oh, because you divided each one. It's the same form. I'm not super picky about that, as long as they're equivalent. Yeah, yeah, yeah. So I know what you did. Yeah, that's fine. Other questions? Okay. All right. Yeah, so do your best, show your work. Start with the problem in its original format, and then rearrange if it takes one or two steps, then show your final form solving for the variable that it's asking for. Okay? And then again, making sure that it's legible, it's neat, it's easy to follow. Okay? All right, so that's set number one. Let's look at set number two. Okay. Set number two is looking at two equations, two unknowns, doing the substitution method. Okay. Along the way, you probably did, like linear problems like this. Okay. These will come up pretty often in the work that we end up doing in statics. So what we want to do is use the substitution method to solve for, we've got two problems here that we're going to solve for the two variables. So we'll start with number 7. And you'll notice that there is fraction form here. So we're going to write it in its up-down format, okay, and not in its slash format. So I am going to label this set number 2. Okay, and this is problem number 7. And I'm going to first write my two equations. So this is going to be b divided by 2 plus d divided by 3 is equal to 4. That's going to be my number 1, if you would. Then I have 3b over 4 plus d over 6 is equal to 4. Okay. So if I go over here, these are my two equations in their up-down format. Now, you'll notice that we're working with fractions. When I do substitution method, all right, I personally like to convert those fractions into their decimal. I think they're easier to work with. If you like fractions, and some people do, some people are like, I'm not afraid of fractions. I'm a little afraid of fractions. Okay. I like decimals better. So I'm going to convert these into decimals first, but if you wanted to leave them in fraction form and do the substitution method, that's totally fine. You would just do the same formatting, except you're going to hold the fractions. Okay. So what I'm going to do is I'm going to say, all right, this is b divided by 2. That's going to be 0.5b plus d divided by 3 is going to be 0.333. I'm going to go 4 decimal places on my d. Okay. When you do decimals and you have, numbers that trail out, make sure you hold at least 4 decimal places inside the problem. Okay. If you round that to 0.3, your numbers are going to be significantly off. So grab a couple extra decimal places there. Okay. And that's going to be equal to 4. Okay. What was that? Oh, yeah, you could do that as well. Yeah, as long as you're holding it in your problem. Yeah. So the question is, can I put that the little line to show that it's repeating, right? Yeah, you definitely could do that. And then my other one down here, this is going to be 0.75b plus 0.1667d is equal to 4, right? 1 divided by 6 is. Yeah. All right. So now that I have these two in this format, and again, if you wanted to hold the fractions, go ahead and do that. I am going to identify my top equation, okay, as number 1. All right. And I'm going to show my bottom equation. You don't have to put a cloud around, as number 2. Okay, you can just call them number 1 and number 2. Now, as we look at these two equations, notice that we have two equations with the same two unknowns. By themselves, I cannot solve for B or D in this one equation because algebra only lets me have one unknown in any given problem, right? To solve for that unknown variable. I have 2. But because I have a second equation with the same two unknowns, now I can use that substitution method, okay? So I've got my two equations. The first step that I'm going to do is I'm going to pick one of those equations to solve for one of the variables in terms of the other. Okay. I'm going to pick number one just because. All right. You could pick number two if you wanted to. There is no right or wrong answer of which one you start with. So I'm going to start with number one. I'm just going to rewrite it. 0.5b plus 0.333d is equal to 4. Okay. Now, what I want to do is I want to solve for one of the variables in terms of the other. So all that means is I'm picking either B or D to isolate it by itself. That's it. Now, since B is the first one, I'm going to pick B. Okay. If you picked D, that's totally fine too. All right. Either one. I'm going to pick B. So I'm going to get B by itself. I'm going to say 0.5B is equal to, I'm going to move my 0.33333D to the other side. So that's going to be 4 minus 0.333D. Okay. And then because I have my 0.5 here, I am going to divide the right-hand side by 0.5. So that means that B is going to be equal to 8 minus, so 4 divided by 0.5, and then I've got to take 0.33333 divided by 0.5, and that's going to be 0.6667D, right? 2/3 D, if you would. Does that make sense? Okay. Now, that's as far as I can go. I have B all by itself is equal to in terms of D, all right? So now we're gonna kind of let that sit there and we're gonna go to, I should put the number one there. We're gonna go to equation number 2. All right. So now we're gonna use this equation right here, but wherever we see B, we're not gonna write B, we're gonna write 8 minus 0.6667D. Okay. So right away, I've got 0.75 times B. B is going to be 8 minus 0.6667D. Okay. And then I'm going to say plus 0.1667D is equal to 4. Okay. So what that's done for us, if we look at this equation now, even though we haven't distributed yet, we only have D's here. We have one unknown now instead of 2. Okay. Instead of 2. So I'm going to distribute and I'm going to combine what I can. Okay, so go ahead and do the math here. And then you can verify that you get the same thing as I do. All right, did you get the same thing as I did? 0.3636 or no? Did I make a mistake? I feel like I did. 6 goes to the other side, that's -2. That's 6. Oh, I know what I did. I know exactly what I did. I'm so sorry. Nope, 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 nope. I was wondering why that was that way. I took 8 times 0.66666. That's why I did it. See, let me do that again. So this is going to be 0.5D, right? Plus 0.1667D. That's what it is. That's why we have an eraser. That's okay. Minus 0.5, 0.1666. There we go. So then now it's going to go 6 over here. Become positive. And this is going to be 6. That's why I was like, oh, that was right. Did you guys get 6 for D?
Yeah, I did.
Yeah, it's 6. Thank you. Okay. What I accidentally did was up here, I took 8 times the 0.6667 instead of 0.75 times. So my fault. And then I corrected it. So then you get 0.5D plus 0.1667D. So that comes to, or negative 0.5D, that comes to 1/3 D. You moved a 6 to the other side. Both of these were negative, became positive, and then D came out to 6. Everybody get that? Okay. Make sure you can. That is the correct answer. D is 6. Right. Once you have D as 6, now we're going to substitute this back into equation number 1. So we used equation number 2 here to get D equal to 6. Now we're going to take and we're going to put our D back into the first equation. Now, the work that we did up here where we solved for B, do you see that? We can take our D is equal to 6 and put it right there. You see that? Okay. So we can go back to equation number 1, but we're going to use it in the form where we had B is equal to. So B is equal to 8 minus 0.6667 times D is 6. So that goes right there. Okay. So we're substituting where D was. So now B is our only unknown. So B is going to be equal to 8 minus 0.6667 times 6. So that's going to be 4. Yeah. And B is equal to 4. I see why you like the converting to decimals. Yes, I know. It's so much easier. I know. Some people, depending on how you learned it, usually is how you like to do it, right? Yeah. 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 And calc it is easier to keep things in fractions. So yeah, if you're used to that, then that's what you do. Okay. So now we want to check. All right. If we go back up to either one of these original equations and we plug in our values. Okay. So for instance, if we take 0.5 times 4, we would get 2, right? And then if we take 1/3 of 6, D was 6, 1/3 of 6, that's going to be 2. So 2 plus 2 is 4. All right. So you don't have to show me that check, but what I want you to do is just kind of go back up and be like, does it make sense? Does that come out to what the 2 equations are? Okay. All right. Any questions on that one? Yes. Right here? So yes, exactly. So up here, we rearranged equation number 1, which was this one right here, to solve for just B. So since we only needed B, B was equal to 8 minus 0.6667 times D. Now we know that D is 6. So down here, what I did was I used equation number 1 again, B is equal to, and I just duplicated this right here, but I substituted in the 6. Yep. You're welcome. Okay. All right, then we have a second one, number 8. We'll do the substitution method again. Okay. Got it, Lexi? Yeah. Or Lacey, sorry, Lacey. All right. Okay, let's look at number 8. Okay. Number 8, we go back over here. It's going to be these 2 equations, okay? So we've got 4 times x plus y is equal to 7. Now, in this case, you'll notice that we have, we need to distribute that 4, so that we can then combine the y's, all right? So if we go underneath here, I want to do that work first. So this is our first equation, but we need to distribute the 4. So this is going to be 4x plus 4y plus y is equal to 7. Bless you. Bless you again. Now we can combine the 4y and the y, so it'll be 5y. So our first equation, number 1, is going to be 4x plus 5y is equal to 7. You guys see that? So we had to do that little bit of work to kind of get it in a standard form. So we had just one x and one y. And then now we're just going to use the second equation here, 5x minus 2y is equal to 0. So I'll go back underneath here. Equation number 2, 5x minus 2y is equal to 0. Okay. So now we've got two equations with the same two unknowns. Any one of these by themselves we wouldn't be able to solve because there's too many unknowns. So that's why we need the second equation and do the substitution method. Okay. Now, you kind of look at these two problems, and if there's one that feels like you would want to work with more than the other, easier if you would to rearrange one variable for the other, you can do that. So does anybody have a preference? Do we want to use equation number 1 or number 2? Sure, 2 sounds good because there's a 0 to deal with, right? And that's kind of easy, right? Instead of the 7. So yeah, let's start with equation number 2. And we will solve for x in terms of y. So all that means is we're going to get x by itself on the left-hand side so that on the other side is everything else, okay? So let's work with number 2 to start. So I'm just going to rearrange it. 5x minus 2y is equal to 0. And now I want to get my x by itself. So I'm going to take my negative 2y and put it to the other side. 5x is equal to 2y. And then now I'm going to divide both sides by 5. So x is going to be equal to, is that 0.4? Yeah, yeah. Okay. So going to kind of hold that because that's as far as I can go here. I've got x in terms of y. Now, since I used equation number 2 here, I'm going to use equation number 1. I'm going to alternate to the other one, okay? And I'm just going to rewrite 4x plus 5y is equal to 7. And now in this equation, wherever I see x, instead of writing x, I'm going to write 0.4y. So this is going to be 4 times 0.4y plus 5y is equal to 7. And now you'll notice we eliminated the x. So now there's only one variable. And once we distribute or multiply, we can then combine. Okay. So if we take 4 times 0.4, it's going to be 1.6y plus 5y is equal to 7. And then we're going to add those two together. It's going to be 6.6y is equal to 7. And then our y, we're going to divide both sides by 6.6. See, let me write that a little nicer. So our y is going to be equal to 1.0606. This one doesn't have quite as nice numbers to deal with. Okay. Everybody get that same value? Okay. So now that we have our y, we want to, since we used equation number 1 here, we want to substitute this back into equation number 2. But we did a little rearranging here where we have number 2 in terms of x. So we can plug y back into that spot right there. Okay. So I'm going to go back to equation number 2, but it's going to be in the x is equal to 0.4y form. Okay. And then now we're going to take that 1.0606 and we're going to put it into where the y is. So x is equal to 0.4 times 1.0606. And our X is going to be 0.4242. And if we plug that back into either one of our equations, our original equations at the top, we're going to notice that it comes out. I know those answers. I worked this one earlier today, I remember. Okay. All right, substitution method. Questions on that? Do you guys remember doing this at some point along the way? Yeah. And we'll get to do it more. All right. We'll get to do it more. Okay. Next section. I'll pull this one underneath here instead of going back and forth on there. The next part, we're going to be doing some converting of units. Converting of units is important not only in our statics class, but in all the other classes that you do. So it's a good place to kind of make sure we've got a really good method to do that. We are going to be doing what we call the ratio method. You will not look on the internet and plug this in on a little calculator and just find the answer. It's not going to magically appear. Okay. I'm going to give you a method that you are going to continue to use that you will always have confidence in. Okay. I learned this a long time ago. Okay. But it never has failed me. All right. So this is the way we're going to always show unit conversions from today going forward. How many have done the ratio method? Yeah. Okay. I'm pretty sure that's what it's officially called. And probably once we see it, you'll be like, oh yeah, we've done this before. So we're going to start with number 9 here. So this is going to be set number 3. Okay. Okay. And this is number 9. And we are going to start with 125 inches. Okay. You don't have to write out inches. Okay. And they want us to convert this to miles. Okay. So 125 inches is how many miles? I don't know why we would do that, but it's the process that we're interested in. So the ratio method. How this is going to be formatted is we're going to be putting our whole number, okay? And it's like, if you remember, it's like it's over 1, right? A whole number is over 1. It's really a fraction, right? The numerator is going to be our 125 inches, and it's just over 1, all right? Then what we're going to do is you're going to show a vertical line and a horizontal line, and this is going to represent our ratio. Okay. And the top is going to be the numerator. The bottom is going to be the denominator because we're going to multiply across the top. We're going to divide by the bottom. But this is where I'm going to put the conversion to something. Now, chances are I don't know how many inches are in a mile, but do I know how many feet are in a mile? Or I could look it up, right? But feet in a mile, most of us know. What's the number? 5280, right? That's the number. So 5,280 feet in 1 mile. So what we're going to do is, well, inches don't go to miles, but do I know how many inches are in a foot? Yeah. So I'm going to go to feet first, and then I'm going to go to miles. Okay. So if inches are on top, inches have to go in the bottom because remember, I'm multiplying across the top, dividing by the bottom. That's the only way they're going to get to cancel. And feet are going to go on top. And this is where I put my conversion in. How many inches are in a foot? I know that one, right? 12. So I'm going to put 12 on the bottom and 1 on the top. Did you ever do a conversion and you were like, do I multiply? Do I divide? Write it out, right? Now we know. So now our inches, as I multiply across the top, divide by the bottom, those cancel, and I'm left with feet. So right now, if I take 125 times 1 divided by 12, I'm going to have however many feet that is, okay? But I don't want feet. I want miles. So I'm going to convert again. I'm going to add another ratio, okay? Now, I got to get from feet to miles. Feet's on top right now. Feet are on top right now. So that means my feet have to go on the bottom on my next ratio, right? So that they cancel. And what's going to go on top? Miles. Yeah, miles. Okay. I'll put miles, right? I know that there are 5280 feet, so that's going to go on the bottom, in 1 mile. 1 mile. Okay. I like how I wrote that. And now my feet cancel top to bottom because I'm going to multiply across the top, divide by the bottom. I'm going to close that up. And you'll notice the only thing that I didn't cancel out is miles. And I also can see I'm going to divide by 12 and I'm going to divide by 5280. And I don't have to worry about, is that right or not? Is it supposed to be smaller or larger? Do you ever have that? No? Or you just put it in the calculator and you're like, ah, that's what it tells me. It magically appears. Okay. All right. So go ahead and multiply 125 times 1 times 1. You don't have to. Divided by 12, divided by 5280. How many miles is that? Should all be doing it. Make sure you can get it. Do you get 0.00197? Yeah, perfect. Okay. Thank you, David. Yep, got that same thing. What was that? Oh, in a decimal, for sure. Yeah. Yeah, the question was, do you want it in a fraction or a decimal? Always in a decimal. All right. So if you weren't sure what the ratio method was, I'm sure that you've done this method in the past, right? Let's do number 10. Number 10 is 86 centimeters. We want to convert that to feet. Okay, 86 centimeters to feet. Now, I don't know how many centimeters are in a foot, but I know how many centimeters are an inch, and I know how many inches are in a foot. So I'm going to do it in a couple phases again. So I'm going to start with my centimeters, 86 centimeters, and I am going to put my ratio, I'm going to put it over 1 because it's a whole number. So whenever I do conversions, instead of doing parentheses, sometimes you may have seen this as parentheses, I always do them as vertical lines. And the reason I do that is so that when you have an equation and you're maybe doing a conversion inside the equation, you can see what part is the conversion and what part is the equation. All right. If you do parentheses, that's fine too. If you're like, I like parentheses, I'm not crazy about your vertical lines. That's okay. All right. But show the top and the bottom, the ratio for each section here. So I personally know how many inches are in, I'm sorry, how many centimeters are in an inch, right? So I know that there are 2.54 centimeters in 1 inch. Okay. Now, tell me why I put centimeters on the bottom. Anyone? Centimeters are on the top to start, right? And if I want them to cancel, when I multiply across the top, divide by the bottom, centimeters has to go in the bottom of my ratio, right? Okay, and then inches on top. Now, inches are left. I don't want this in inches. I want this in feet, right? So now if I'm in inches, if inches are on top, inches are going to go on the bottom over here. So I'm going to put my inches over here. So that means my feet have to be up on top. How many inches are in a foot? 12, right? So 12 is going to go on the bottom. That means my inches are going to cancel. And now the only thing that's not canceled is feet, and it's in the numerator, which is exactly where I want it to be because this is a whole number. So now I'm going to multiply across the top, divide by the bottom, and I'm going to get my answer in feet. So 86 divided by 2.54 divided by 12. Okay. I didn't do it second time, but I got 2.8215 feet. Okay. Okay. These are fun, aren't they? Just excited. So good. All right, number 11. Keep going. This one, we have 100 square inches or inches squared is equal to how many square feet? Okay. Now, notice that there's a power here. So I'm going to show you something or make sure that you do this. So I'm going to start with 100 inches squared. Okay. going to put that over 1, and I want to get it into feet squared, right? Now, I know that there are 12 inches in a foot. So since the inches is on top here, that 12 inches is going to go underneath, right? 12 inches here. And I know that 1 foot is going to go on the top. Now, because this is square inches, I can't do this just once because if I look, my inches will only cancel out one of the inches here. This is inches times inches, right? When it's inches squared. So only one of these goes. I've got to do it 2 times in order to clear the square. Does that make sense? Okay. So I've got to do this one more time. I've got to do the 12 on the bottom again, 12 inches, and 1 foot on top. And then it clears that square. Okay. So when you have a power, you have to do the ratio as many times as the power. So if this would be a cube, we would do it 3 times. Okay. All right, so now we're going to take 100 divided by 12, and that's what we're going to get for square feet. .694 about, and I think 4 repeating. Okay. Number 12. Number 12 is 64 cubic meters. Okay. And I want to find out how many cubic inches there are. So 64 cubic meters to cubic inches. Okay. I'm going to put this over 1. Now I got to think about it. I don't know how many inches are in a meter, but I do know how many centimeters are an inch, and I know how many centimeters are in a meter. I can do it that way, right? Okay. So I'm going to go to centimeters first. Now I have to do this 3 times, right? Because I'm a cube. So I'm going to put 1 meter on the bottom and 100 centimeters on top. That's 1. Then I'm going to do 1 meter on the bottom again, 100 centimeters on the top. That's 2. And 100 centimeters on the top, 1 meter on the bottom. That's 3. So 1, 2, 3 takes care of the meters cubed. If you only do it once, like I said, you only clear 1 of the meters. You've still got 2 left over. Okay. All right. And then now I'm in cubic centimeters. I want to get to cubic inches. Now I'm going to do this 3 more times, right? And this time my centimeters are going to go on the bottom, okay? Centimeters down here and inches on top. What's the number I'm going to put down on the bottom in the centimeters section? 2.54, exactly. So 2.5, gotta scoosh it in here. 2.54 centimeters to 1 inch on the top. And I need to do that 2 more times. 2.54, I'm going to put centimeters down here. 2.54 centimeters down there. So 1, 2, 3 centimeters cancels out the 3 on top. And then I've got 1 inch, 1 inch. And I've got inches times inches times inches. Cubic inches are left over. So now to get my number, I'm going to take 64 times 100 times 100 times 100 divided by 2.54, 2.54, 2.54. Okay. Put that one down here. I will round it the 19 to 20. And that's going to be inches cubed. There we go. Now you will never do conversions the same again. You'll always do it this way. You will never trust those calculators online. Okay, maybe you will. All good. Okay, cool, cool, cool. Number 13. I'll write it out here. This one is 14 PSI, okay? So if we look here, we have 14 PSI. What does PSI mean? Pounds per square inch. So what we need to do is we need to expand that out. So PSI, we're going to put 14. We're not going to put PSI. We're going to put pounds on top. Per is our horizontal line for our fraction. And then inches squared on the bottom. So if you would, that's an expanded out unit. So PSI is just an abbreviation. It's pounds per square inch. Okay. So now to convert this, we need to convert to newtons per centimeter squared. Okay, newtons per centimeter squared. I'm not worried about the centimeter squared, but I'm a little concerned about the newtons, right? To pounds. How many newtons are in a pound or how many pounds are in a newton? I don't know. I don't have that one in my brain. What can we do? I have this really cool smartphone next to me. I don't know if mine's that cool, but you can look on your smartphone. Find it out. Let's go. Let's look. What do you guys find? How many newtons or pounds, one way or the other? What do you get? 4.448 what? Newtons per pound. I don't know. Tell me. Are you're afraid of that answer? You sound concerned. Like, I think we got to be confident. The magic of Google. Yes, David, absolutely. Okay. Somebody else. What else? What else? So we've got 4.448 newtons in 1 pound. That's anybody else got that? Deborah got that? 1 pound force. Yep, 4.448. All right, that sounds good to me. It's not in my head. I don't know. Okay, I always got to look it up. Okay, I want to make sure you guys know how to look it up. So that's what we're going to do. So we know the number now, right? We know that there are 4.448 newtons equals 1. I'm going to put pounds there. Okay, that's my conversion. That's my conversion. So pounds are on top here, right? That means that 1 pound is going to go on the bottom here. And on top is going to be 4.448 newtons, capital N. Okay. Multiply across the top, divide by the bottom. My pounds are going to cancel. Okay, so newtons per square inch is what I have. I need to get to newtons per centimeter squared. Okay, so now I'm going to add another ratio. Inches squared is on the bottom. So that means I have to go inches on top and inches on top, 2 of them, right? I know that 1 inch is equal to 2.54 centimeters. That's going to go on the bottom. And then 2.54 centimeters on the bottom. So my inches, 2 inches cancel out the inches squared, and I'm left with newtons per centimeter squared. Do you see that? So good. My goodness. You guys, I bet you can't wait to do the homework. I know. You're welcome. You're welcome. Centimeter squared. Ran out of room there. There we go. Did you guys get 9.652-ish? Okay. So good. Last one in this section. Number 14, 55 miles per hour to feet per minute. Go ahead, set it up. You guys can do this. You have the technology. You have the skills. All right, so we're going to be 55. Now, this is MPH. That's an abbreviation again, like PSI was. We got to go miles per hour. So we have to expand it out. Miles are going to be on top, per hour on the bottom. Okay. So we've got our little fraction here. And we need to get to feet per minute. No, yeah, feet per minute. Feet per minute. Go ahead and do it. See what you come up with. And I'll do it in just a little bit. Did you end up with 4840? Awesome. Okay, cool. Any questions on that section on unit conversions? Okay. All right, then we have one more section to do. Okay, and our last section is set number 4, rectangular components. So what we want to do for this one is solve for the X and Y components for each one of the forces identified in 15, 16, and 17. It says make sure to show a diagram and add labels as directed. Okay, so we're going to do number 15 first. This is a 56-pound force at 55 degrees. Okay, so how I have these labeled, if you would, is if we look at a standard Cartesian coordinate system, right? And we know that as we start on the right-hand side, this is 0 degrees, right? 0 degrees. And then we go in a counterclockwise direction. This would be 90 degrees. This would be 180 degrees. And this would be 270 degrees. And then back would be 360 all the way around, right? First quadrant, second quadrant, third, and fourth. Okay. So the way this is called out is I'm referencing the standard 0 degrees. So for our first force, okay, so I'm going to start on a new piece of paper here because I'll try to get all 3 of these on the same piece. Not that it matters, but this is set number 4. Okay. So when I sketch this, I want to sketch this large enough so that I can show my vector, label everything neatly, and I can make something out of it. Don't make this super small. All right. I'm going to make mine. I'm going to make an X and a Y axis. I'm going to be in the first quadrant because my angle is at 55 degrees. Okay. So about this big. All right. I'm going to draw proportional. Now, if you know that you're not great at straight lines, this is reasonably straight. This is a sketch to straight line. All right. Not expecting you to be as good as me. I get it. No, I'm kidding. Straight lines. Get out a protractor or a scale. All right. And just use a straight edge then. All right. So reasonably straight. And then we're going to, in proportion, draw a vector from the origin going out, and we're going to show that vector with an arrowhead. Forces are represented by vectors. We will be talking about vectors a little bit more in module 2, but every vector that we have when we represent a force has to have an arrowhead because we have to know which way it's going, okay? So we're going up and to the right here, and this is 56 pounds. So we're labeling the magnitude of the force as 56, and its units are pounds. So make sure you add those, okay? Now the angle that we have here is 55 degrees, all right? This is our x-axis. This is our y-axis. Now we want to identify, calculate, and show the x and the y components, okay? The x and the y components. So to show those, through the tip of our vector, we're going to draw just a dashed vertical line parallel to the y-axis and a dashed horizontal line parallel to the x-axis. Where our dashed lines cross the x and the y axes is going to represent the length of the x and the y components, okay? For the x component, we're going to start the tail of the vector at the origin, and the tip is going to go to the intersection we just created. It is going to be along the x-axis. It is an x component. It lies on the x-axis. Okay, it doesn't float. You'll know what I mean in a little bit. The y component. The y component is on the y-axis, and it is going to start its tail at the origin, and its tip is going to point towards the intersection we just created. Now we're going to label each one of these components. We're going to call fx and fy. Don't call them x and y. X and y are the axes. F represents a force. Force X, force Y. Okay, they're going along those axes in those directions. Okay, so you have to draw this diagram. Now, we want to calculate what is the magnitude of Fx and Fy. Okay, now since we have a standard Cartesian coordinate system, we can kind of look at this little section right here, right? This is a 90-degree angle. This is a right triangle, right? Okay, so we can use our right triangle trig to calculate these, right? Okay, do you guys remember SOHCAHTOA, right? Okay, so sine, cosine, and tangent are what's available to us to solve for the unknown sides. So we know a hypotenuse, right? 56 pounds. We know an angle, and we're going to start with our x component. This is the side adjacent, right, to the angle. Which function, sine, cosine, or tangent, would I use to solve for this? Cosine, exactly. Yep. So cosine, so we would write this out, cosine of 55 degrees is equal to the side adjacent, fx, divided by the hypotenuse, 56 pounds, right? Now, to solve for fx, that's my unknown, I'm going to multiply my 56 up. So I'm going to have 56 pounds times the, cosine of 55 degrees is equal to fx. Okay, so now we're just going to do that math, right? 55 cosine, 56 times. So you should get 32.12 pounds. Make sure you add your units. You could put lb here if you wanted to, but you have to add your units. This is a force. Not only does it have direction, it needs an arrowhead on the line, but it also has to have units. Degrees. Degrees. Yep. Yep. Make sure you're in degrees on your calculator. Good. And then equal to fx. And then we're going to put a box around that answer, okay? Because it was asking for the components. What's the magnitude of the component? All right. And now we're going to do the Fy. Now, the Fy is here along the y-axis. All right. It is equivalent to out here. This is what I meant when I said do not float the components. Yes, it's equivalent out here, but don't draw and label Fy out here. Fy is on the x-axis. Okay. It starts at the origin and points up. It's equivalent out here. Does that make sense to everybody? All right. I know sometimes, I don't know, math teachers allow you to float those vectors. And it's really, I'm not going to say, I understand the visualization of it, but the problem is the application of the force is here at the origin. Does that make sense? Okay, so it's important to draw it on the y-axis. So this one, because it would be the side opposite from the angle, and we have the hypotenuse, which function this time? Starts with an S. Sine. Yes, we're going to use a sine function. So the sine function, sine of 55 degrees, is equal to the side opposite, Fy, divided by the hypotenuse, 56 pounds. Okay, multiply my 56 pounds up times the sine this time of 55 degrees is equal to Fy. Should get 45.87 pounds is equal to Fy. That sound familiar? So when you show the work here, you're going to show what we see over here on the right-hand side using the sine or the cosine for X and Y. You're going to make sure that each one of these answers has the units, and the units are going to come from whatever the hypotenuse was. And then your diagram is going to have the arrowheads going in the right direction and on the X and Y axis labeled. If you're solving for an FY, I should see an FY in your diagram. If you're solving for an FX, I should see an FX in your diagram. Okay? Questions? Okay, let's do another one. So good. Let's do number 16. So this was 15, number 16. All right, number 16, it says we have 10 kips. Anybody know what a kip is? We don't hear it much. It's actually an English unit. It's 1,000 pounds. So instead of saying 10,000 pounds, we say 10 kips. Okay. And we're going to see that quite often going forward. So a kip, bless you, a kip is 1,000 pounds. All right. So 10 kips at 125 degrees. Okay. So going back over here, since we're past 90, we're going to be in the second quadrant. So we're going to show the Y and then the X going to the left. Okay. So this time we're going to be like this and like this. All right. So this is going to be my Y, and technically that's my negative X. Okay. Now, since this is 125 degrees, okay, that means that 90 is off of here. And when I'm showing my force of 10 kips, right? Showing my force of 10 kips going up and to the left, this is the angle that's left over, right? So 125 minus 90, what do I get? How many degrees are in here? 35 degrees. Yep. So this is 35 degrees right there. Okay. So now we want to kind of do that same thing. We want to show our dotted lines going over to the X and to the Y axes. We're going to show our X and Y components. So our FX this time is going to point to the left. Our FY is going to point up again. Okay. And then this time we have the 35 degrees. And then if you would, there's a right triangle right there, right? Or a right angle. So that we have, if you would, a right triangle there with 35 degrees. Okay. So let's solve for the magnitude of each one of those components. I'm going to start this time with Fy. Okay, Fy. So you'll notice that I have my 35 degrees here. I know my hypotenuse is 10 kips, and my Fy is the side adjacent. Which function am I going to use? Cosine again. Yep. So cosine of 35 degrees is going to be equal to the side adjacent, Fy, divided by the hypotenuse. So I'm sorry, not 56, 10 kips this time, 10 kips. Okay. So then multiplying the 10 kips up times cosine of 35 is equal to Fy. So you should get 8.19 kips is equal to Fy. Remember, kip is 1,000 pounds, so this would technically be 8,190 pounds is what we have here, but we write it in kips, okay? All right. Then we're going to do the X component. Now remember, the X component, it's equivalent to this side out here, but it's not located there. So do not show a floating X component here. It has to be on the X axis, all right? But as we look here, if it's an equivalent side, we have our 35 degrees here. That X equivalent side is the side opposite, right? And then we have our hypotenuse. So which function would that be? Sine again. Yep. Mhm. So we're going to use sine of 35 degrees is equal to fx divided by our 10 kips, which is the hypotenuse. So the 10 kips times the sine of 35 degrees is equal to fx. Should get 5.736 kips is equal to fx. All right, questions? Again, if you calculate, you identify an fx, which you should see an fx over here on your diagram labeled. Fy, Fy. Make sure every one of your vectors has an arrowhead and that you have units, for each one of your values as well. In this case, kips, yes. I know that's a hard question. So for instance, the question was, do you get too picky on the decimal places? I usually look to 3 significant digits. And if for instance, let's say this was 8, and I forget what the number was. This number was 8.915. Okay, because it was such a small fourth decimal or fourth digit, I dropped it. Okay, here you're going to notice this was 5.7357. So I added the third. Okay, so I kind of use that discretion with a minimum usually of 3 significant digits. Is that helpful? Okay. When in doubt, add 1 or 2. It's just better. It's just better. The book always usually uses 3 significant digits all the way through. Sometimes you get a lot of rounding error in the problem then. As a final answer, I think it's fine to round at the end, but why not hold a couple decimal places inside the problem when you're using your steps? Okay. So. And usually when you see those differences, if you can be like, that's rounding, not a huge deal. But if you see some significant digits and it was rounding, then you were not holding enough earlier. Does that make sense? So round final answers, try to hold more decimals as you go along. Okay, our last problem. I know. Sad stuff. Number 17. Okay. Number 17 is 25 kilonewtons at 211 degrees. So if we look back at our coordinate system, we're past the 180, we're down in the 3rd quadrant. Okay, so go ahead and create your little diagram. 3rd quadrant, so this is going to be negative y and negative x this time. I take 211, minus 180. Maybe show something like that. I can make my y a little bit shorter. All right. Go ahead and draw the rest of the diagram here. I'll draw mine in the background and you can just compare to make sure you have all your elements. Okay. Should be seeing your Fy go down this time. I'm sorry. And then your Fx go to the left. I labeled them both Fy. Fx is going to the left. Okay. And then the magnitude of our hypotenuse is 25 kilonewtons this time. All right. So now we want to solve for each one of our variables. Which one do we want to start with, or each component? Which one do we want to start with, the x or the y? Yeah, let's start with the X. I like that idea. So if we look at our 31 degrees, okay, and we have a hypotenuse, the side adjacent is fx, right? So which function? The cosine, yep. So we're going to say cosine of 31 degrees is equal to the side adjacent, which is fx, divided by 25 kilonewtons. Okay. Then multiplying the 25 kilonewtons up times the cosine of 31 degrees is equal to our fx. And we're going to get 21.4. This is one of those two. So 21.429 kilonewtons is equal to fx. If you would do 21.43, that's totally fine. Okay. But like I said, once I have some rounding numbers, I feel like sometimes, unless they're smaller, I want to add them. Then to get the Fy, remember my 31 degrees is here. The equivalent side is out here, but the location of Fy is on the y-axis. So it has to be showed there. So if we look 31 degrees, Fy would be equivalent to the side opposite, and I have the hypotenuse. So which function this time? Sine. Yeah, it's always sine or cosine, honestly. So sine of 31 degrees is going to be equal to our Fy divided by 25 kilonewtons. And we multiply the 25 kilonewtons up times the sine of 31 degrees is equal to Fy. Should get 12.876. And that's going to be kilonewtons is equal to Fy. Make sure that when you show and you're solving for something, make sure that you show the variable here as well. Don't just, do 12.876 kilonewtons. I don't know what that's equal to. You have to add your variable, okay? All right. I think that brings us to the end of our practice problems, okay? So we did get through all of the practice problems here. So now, if you have everything all complete and you feel like you're ready to hand in, you would submit this then for the practice problems, okay? How to submit, okay? How to submit. Let's go over to our practice problems assignments in Canvas, okay? Now there's a couple ways that you can do this, and I find that students, if you have the app on your smartphone, okay, you have a couple options. You first of all can use, there's apps that you can get called like Tiny Scanner, or there's some other ones I think in the math department they have you use. What is that one called? Cam Scanner. Yep, that's another one. So you guys have done this before, right? So what you want to do is you want to, create a PDF of the work. Now you can either do PDF or you can do JPEG. All right. And then what you're going to do is you can, on your phone, upload it to the assignment after you take the picture. Students seem to like that the best. Another way, if you don't have an app, you can take a picture of the of the sheet. Now, when you take your picture, make sure you're directly above it, not at an angle, because I got to see it like it's a flat piece of paper. Does that make sense? So you want to be directly above. And then also make sure that the image is nice and crisp and it's not blurry, okay? But if you don't have a Cam Scanner app or you're not sure how to use it, you can take pictures and you could also submit the JPEGs directly into the file. You don't have to go through or make a PDF. Does that make sense? Okay. The third way to do it is you could take your pictures and you can pull them into like a Word document. And then you can, populate with however many pictures you would have, one right after another, and then you can submit the Word document. So As I mentioned those, if you would, 3 different ways of doing it. Does anybody need to see a demonstration, or do you feel like one of those ways you've used before in other classes? I'm going to watch virtually here too. Does anybody have a question on how to do that? And really the key, because I can see JPEGs, I can see Word documents, I can see PDFs. Okay. The main thing is make sure whatever you submit, I can read. Okay. That's the only requirement I have. So just double check those files before you upload them. All right. If let's say you upload it and it's blurry, I am not going to be like, that's a 0. Okay. What I am going to do is probably mark it 0 because I have to put something in so that you submitted. But then I'm going to say, hey, just retake the picture and resubmit it. All right. So don't think I'm that much of a jerk. But I do like you to check them before you put them up because then we can, minimize having to resubmit. Okay. All right. So that's practice problems. We already got one assignment done here the first night that we're here. You got 20% of your grade starting to build. Now, once you get those uploaded, then what I'm going to do is I'm going to look at them. I'm going to go through, I'll make some notes. All right. And if need be. All right. And again, remember practice problems are 10 or 0. If we look back at our calendar, all right. Practice problems down here. Practice problems for module 1 are due on Friday. Okay. You don't have to get them in on Friday because you have what? A 7-day grace period. So I don't want anybody to stress about getting them in there, but you probably have most of them done right now or completely done that you can do it. All right. So I encourage you to do that right away. Now, application problems are also due on Friday. Let's look at the application problems. Okay. So if I go back to technical statics, as I told you, the practice problems are kind of like they mimic the application problems. So if I click on Module 1 application problems, you've got another file here. So I'm going to open up that PDF. You can read the instructions up here. Okay, each one of the individual problems is worth 2 points each. So this assignment is worth 50 points total. Okay, this one I grade per problem. All right. So as we go through here, you're gonna notice that these look pretty similar to the practice problems that we did, but there might be, a couple more. All right. So what you're gonna do is using that same formatting that we did this evening, you're gonna then do these 10 problems for the algebra set in the application problems. Okay. Then you're gonna go to the next one. You've got 4 substitution, 2 equations, 2 unknowns to do. Again, same formatting that we did in the practice problems. Set 3, you've got some converting of units using the ratio method. Okay, only way that you can do it. Yes, every one of these problems, there are 4 different ways that you can approach it, but how we did it in class, how we formatted it, and then the ratio method, you have to do it that way. Okay, and then lastly, the components of the forces that we see here using the formatting again that we did in the last problems that we just looked at. Okay. Now, for module 1, I covered all the content that I wanted to, including got through all of the practice problems. Okay. So what that means to us is when we look at our calendar for Friday, this will be a virtual workday. Okay. It will be a virtual workday. Now, in order for you to, let me say this, it's required if you don't have them submitted, okay? If you submit the homework before Friday, you don't have to come on Friday, all right? But that means it's all done. Don't be like, 2 problems in set 1 and say, oh, I handed it in. No, it's got to be completed, reasonably completed to the best of your knowledge. You don't have to have it all perfect, but it doesn't mean that it has to be 100%, but it has to be submitted. Yes. Well, let me explain. So basically, if you have it already in, then I'm saying I look before class starts, how many people have it in or who has it in and who doesn't. The people who don't have it in are required to come to the virtual lecture. Okay. Now, that doesn't mean that it's a penalty. Remember, work time means you have me available to answer questions. Okay. So that means that, all right, I already had Friday nights, 7:30 or 5:30 to 7:30 kind of blocked off because I knew I had class. If you don't feel confident in the homework or you have questions, come to that session and ask me. We'll go over them. All right. If you have it done and you feel confident, you're like, oh, I'm good to go, then you don't have to come. Does that make sense to everybody? All right. Now, after this week, all right, going forward, if you have any missing work, you have to come. All right. So it's not so much, it's kind of an incentive to stay caught up to, because then Fridays become an option for you instead of a requirement. Does that make sense? Okay. If Fridays are a work day, remember, I'm not saying all Fridays are work day. I'll try to make Fridays work days, but there might be some that we have to take just because of, how we got through the material or didn't. All right. But this Friday is a work day. And if you feel that you need some, extra reinforcement, do come and we can work together. And I'm happy to go over things with you. Otherwise, I look forward to seeing your assignments. I'm excited. Okay. Question.
So in the event, say. In the meeting, so if we check in, obviously we're there, and if you want to.
Oh.
Like tell you we're done, have you confirm that before we leave, or?
Oh, so the question is, so when we're in our virtual lecture, let's say you're working on things and you complete it before the 2 hours is up, right? And you're like, all right, I'm done. I want to go. Do you, can you leave or can you just check out? Yes, yes to all of that. If you submit and all of a sudden you're gone, I'll notice that you submitted. Yeah, so you don't have to be like, Kelly, I'm leaving. Can I go? Or I'm already done. Your requirement is as long as you're done. If you leave the time or you say to me, oh, I've got something going on and you don't have the work submitted, that's an unexcused absence. Okay? Because if you have something and you have something on Friday, then get the work in. All right? Does that make sense? All right. So just because you show your face doesn't mean you can not hand the homework in. It doesn't count as then you're there until you either hand in or you use the time to work. And even if you don't get done, that's okay. You don't have to get done in that time, but then you have to be there the duration. Is that helpful, Josiah? Okay. Anybody else have any other questions about it? As we kind of get into things, you'll get to know the rhythm of what we do. All right. And I think you'll love it. Statics is amazing. When I went through the program years ago, because I did finish this program at a different college, statics was like my favorite class, and it's actually probably my favorite class to teach too. So I'm excited for you guys. It's good. So good. All right. Okay. That's all that I have for tonight. Feel free to stick around if you want to work on application problems. I'm here because technically we're scheduled until about 9:30, but if you're done for the day, you can leave as well. Okay. All right. Have a great night.